compound interest investments with regular additions to the principal. So now we have Roberto. Now he plans to have a gap year and travel. He has already saved $2,000 and thinks that he can save an additional $100 each month that he plans to add to his savings account that pays interest at a rate of 4.5% per annum, compounded monthly. Model this annuity using a recurrence relation of the form V0 equals principal, V n add 1 equals R Vn add D, where Vn is the value of the investment after n number of payments. Additions to the principal have been made. So now we have to find the common ratio. When we do that, we need to find the monthly rate. So we have 4.5% per annum. We have to divide that by 12, then divide that by 100 and add 1. Now we get R equals 1.00375. Now we can use the recurrence relation. So our initial value is 2,000. Vn add 1 equals 1.00375 Vn add 100. Roberto's annuity can now be modelled. Use your calculator to determine recursively the value of the investment after Roberto has made 4 additional payments to his investment. So what we need to do is use a CAS calculator, like you see here. First, we go to Sequence, we clear all, and we simply type in our recurrence relation. Remember, AN is in the same context of VN. We tick the box, and now we go to the table, and now we have all of our payments. You double check 1.00375. It's Vn instead of An. Add 100. And if you want to see the exact value, you can click on the table. So let's go through the next payments. Four payments or months ends up being $2,432.42. And as you can see here, same as the CLASSPAD. What is the value of the investment after 1 year? Well, because we know these are monthly payments, we need to find the value for V12. So what we do is we just keep going down. It'll be this one here. So $3,316.94. Now we're going to fill out the following table for Roberto. What you are going to see is all of the working out as we go. We know that the payment received all the way through is 100, so we can fill in the gaps there. Now we have to work out the interest. Here we can multiply $2,107.50 by the interest per month divided by 100. So we multiply that by 0.00375 and we get 7.90. Now what we can do is add that to 100. Now what we can do, because we are increasing the principal, we add $107.90 to the balance. And now we just keep going with the same process. Now if you compare your solutions to the CLASSPAD, what you will notice are slight differences in rounding, because using this process with the table, we are rounding as we go. And there we go, that's our table completed. Adding to an investment on the CLASSPAD. So N is the total number of payments. The next one we have the annual interest rate. PV is the present value of the investment, so the amount that you give to the bank, so enter as a negative number. PMT is the amount paid at each payment, so the amount that you pay to the bank each month, so enter as a negative number. FV is the future value of the loan or investment. The future value of the investment, so it's positive, as this is the amount you receive from the bank. PY is the number of payments per year. CY is the number of times interest is compounded per year. It is almost always the same as PY. In this example, Tom invests $400,000 at 6% per annum compounding monthly. He makes regular deposits of $400 per month into the account. What is the amount of the investment after 5 years? So here is the financial solver. In this case, we've got N being 5 multiplied by 12 because there are 5 years and we're paying per month. The interest rate is 6%. Tom is investing, so therefore it's a negative value, so therefore negative 400,000. Tom is also depositing money each month, so therefore it's negative 400. And PYCY is 12 because we are compounding monthly. When we hit the FV key, we get the following. So therefore the investment after 5 years is $567,448.07. In this example, Sarah saves $450 per month in an account which pays interest of 5.7% per annum compounding monthly. Her initial balance is $0. She adds monthly deposits of $450 to the account. How much will she have at the end of 6 years? In this case, N is 72. Why is that? Because we're looking for 6 years of payments. Therefore, we have monthly payments. So therefore, it's 6 multiplied by 12, which gives us 72. The interest rate is 5.7. The present value is Sarah's initial balance of $0. Sarah is paying $450 per month, so therefore it's negative 450, and PYCY is 12 because it is compounding monthly. So we hit the FV key, and therefore we are left with the investment after 6 years is $38,521.98.